All right, guys, so this is the video for 6-4, and notice 6-4 is something we have done a million times already. Okay, we're talking about transformations. So transformations of exponential and logarithmic functions. Okay, now these transformations, if you learned them before, they're the same thing. Okay, they look the same. It's just a different kind of function we're applying them to. Okay, we're going to do a little bit with graphing too. So this is the chart for exponential functions, and I just want to really quick go over graphs of exponential functions. Okay, so if we have exponential growth, okay, the graph looks something like this, where we ride this is our asymptote, we go up, we cross at 0, 1, and then we go up. Okay, remember this is 0, 1 because anything to the 0 power is 1. Okay, so an exponential growth would look like this. And the asymptote, remember the asymptote is kind of that imaginary line that it gets closer and closer and closer and closer to, but it never gets to. Okay, so our asymptote for an exponential growth function would be this y equals 0. Okay, now exponential decay. So same concept, but this time we're going down. So here we're going down, down, down. We cross once again at 0, 1, and then we ride this line forever. So this once again is 0, 1. Okay, and our asymptote, although the graph looks kind of like opposites, our asymptote is still right here. I didn't do that. And that is at y equals 0. Okay, so that's something that's going to be important today. Now remember, an asymptote is that imaginary line that we continue to get closer and closer and closer and closer and closer to, but we never reach it. All right, so let's look at some exponential function examples. Okay, we're talking about transformations once again. Okay, so on A, we go from 3 to the x to 3 to the 3x minus 5. Okay, now remember when we're just looking at graphs, we want to follow a certain order. Okay, hopefully you still know this order. Okay, but the orders we look to see if we're moving left or right first. Okay, the next thing we're looking for is a shrink or a stretch, and if there's both, it doesn't matter which order those go in. Okay, then we're looking for reflections, which are negatives, and then we're looking to see if we're translating up or down. Okay, so if I look at this, okay, the first thing I want to check is, are we moving left or right? Okay, so yes, this tells us this minus 5 means we're moving right 5. Okay, and if you remember, that means our new function, if we start with 3 to the x and we move right 5, that means we have 3 to the x minus 5. Okay, so we're still not to where we should be. Okay, so we're going to move right 5. We're not done yet. Shrink or stretch. Okay, well, this 3 right here tells us that we do have a shrink or stretch. There we go. Okay, so it is only applied to the x. So remember, that's a horizontal. And when we're horizontally, remember we have to do the reciprocal. Okay, so this would be a horizontal shrink by the reciprocal of 3 is 1/3. And if we do that to this function, we get 3 to the 3x minus 5, which is exactly what we have. So this is the only two things we do. Okay, let's look at another one over here. Okay, so we go from e to the negative x, and we're going to finish with 1/8 or negative 1/8 e to the negative x. Okay, so the first thing we want to look at is, are we moving left or right? Okay, no, we're not moving left or right, so we move to the next. Do we have a shrink or a stretch? Well, this 1/8 is a shrink or a stretch, okay? And because it's applied to the entire function and not just the x, okay, this is going to be a vertical shrink with a scale factor of 1/8. Okay, so after we do just a vertical shrink with a factor of 1/8, our new function, if we start with e to the negative x, would be 1/8 e to the negative x. Okay, so we're close. The only thing we have to address now is this negative. Okay, well, this negative is The next thing we would check for is reflections anyway. So yes, we do have a reflection. Okay, and because this negative is applied to the entire function and not just the x, okay, it'll be a reflection over the x-axis. Okay, and if we take this and reflect it over the x-axis, we'd get negative 1/8 e to the negative x, which we're where we need to be. All right, so I want you to go ahead and pause this and try to do C and D on your own. All right, so hopefully you paused these and worked these out, and when you did, you should have gotten these here. Now, these should have been very easy because they almost mirror what we did up here, so hopefully you could do a little bit harder ones too, but this here is what you should have gotten. All right, so let's look at example 2. Okay, so we're going to do the same thing we did before, but now we're going to talk about the asymptotes and the range. Okay, so I'm going to start by doing a graph because I think that makes finding the asymptotes and range easier. Okay, and we do have an exponential growth function. Okay, so we start with e to the x, and so e to the x looks, ooh, probably should have went straighter up, but that's okay. Looks like this. Okay, and remember the start of e to the x, because it is exponential growth, is the y equals 0. Okay, so really moving this up or down is what's going to change the asymptote here. Okay, so let's go ahead and just describe the transformations. Okay, so e to the x plus 3, this x plus 3 tells you we are moving left 3. And remember, left and right is the first thing we're looking for, so left 3. Okay, now the only other thing that this has that differs is this plus 2, and that tells me that we're going to move up 2, and up and down, remember, are always the last thing, so that worked out good. Okay, now I like to draw this. So if we move left 3, that would be e to the x plus 3. Okay, and then if we moved up 2 from that, it'd be e to the x plus 3 plus 2. Okay, so if I were to graph e to the x plus 3, if I were just to move left 3, it would look something like something like this. Okay, where everything is just the same, but to the left 3. Okay, now when I move up 2, I'm going to take this graph and move up 2, and it's still going to be the same, but it's going to be 2 higher. Okay, so when I move up 2, my asymptote that was at y equals 0 is now at y equals 2. Okay, so my asymptote is y equals 2. Okay, now when you write this, make sure you write y equals 2 and not just 2, because y equals 2 is the equation of the line. That's what an asymptote is. An asymptote is a line, okay? 2 is not a line. Make sure it's y equals 2. Okay, now my range, my asymptote helps determine my range. So notice my range, my y value, everything above 2, or you can do y is greater than 2. Okay, remember it's not greater than or equal to because it never equals 2, but it is greater than 2. We could write that in interval notation from 2 to infinity. So, and because it's just strictly greater than, we would use a parentheses. It's not equal. We could write from 2 to infinity. That's how you'll do it beyond now. All right, let's go ahead and do another example. Okay, so once again, we're going to start with e to the x, which is right here. Okay, so after I have my e to the x, okay, I'm going to go ahead and look at the transformations and kind of sketch it as I go. Okay, so the first thing I want to look at is, are we moving left or right? Okay, well, we see this plus 2 here, so remember that means we're moving left 2. Okay, so if we move left 2, it'd be the same equation here. Everything's going to be to the left 2 of it. So this would be like e to the x plus 2. Okay, now the next thing I look for is, do we have a shrink or a stretch? Okay, no, we don't. Do we have a reflection? Which, yes, we do. Okay, this negative right here, okay, because it just affects the x, that tells me I'm reflecting it over the y-axis. Okay, so if I reflect this over the y-axis, that means I'm now something like this. Okay, so this would be e to the negative x plus 2. Okay, now the only thing left to do is look for up and down, and we do have a minus 1 at the end. So that tells me, in terms of transformations, I'm also moving down 1 unit. Okay, so I can take this here and I can move it down 1, which will just bring me to this point. Okay, and so this red then would be e to the negative x plus 2 minus 1. Okay, now because I've sketched them all, to me that makes it a whole heck of a lot easier to find the asymptote in the range. Okay, remember with just e to the x, my asymptote was right here at y equals 0. Okay, nothing except this minus 1 shifts that asymptote. The minus 1 now tells me our new asymptote is at y equals negative 1. So my asymptote would be y equals negative 1. Okay, now my range, okay, I'm everything above negative 1. My y values are everything above negative 1. So I could just say y is greater than negative 1, not greater than or equal to, because remember we never get to asymptotes. Or I could write that in interval notation, which I would prefer. That is from negative 1 to infinity. And of course we use parentheses on both. Parentheses on negative 1 because it doesn't equal negative 1. And then we always use parentheses for infinity and negative infinity because as a technicality, we never get there. All right, I want you to pause this and then try these two on your own. All right, so this is what you should have gotten with the sketches. Okay, I do want to make note that when we write this in interval notation, okay, we do write the negative infinity first because it's smaller, okay, than the 0. We always write smallest to biggest.